Welcome to True Projects. In this video, we are going to explain about a project titled Emotion Detection from Microblocks using Novel Input Representation. So now coming to the introduction part. In the era of technology, microblogging has surfaced a potential medium for people to convey their ideas, viewpoints and feelings. The extensive data produced on these platforms offers an exceptional chance to gain insights into human emotions. Detecting emotions, a crucial aspect of natural language processing, allows us to explore the sentiments, temperaments, and emotions conveyed in microblocks at a more profound level. So now coming to the objective path for this project is to put the boundaries in the realm of emotion detection by introducing and assessing a fresh method for representing and examining microblock data. This research is underpinned by a set of distinct goals and aims. Foremost among these is the primary goal to improve the precision and efficiency of emotion detection in microblocks. Traditional techniques frequently face challenges in grasping the intricacy of emotions conveyed in microblock content, encompassing not only textual content but also images, emojis, and various other multimodal elements. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and C1 for visualization are important. Second, here we have loading the dataset. In this step, you load your dataset into a working environment. The dataset contains the data you will use for analysis, training, or marking the predictions. Then we have data processing. Dropping the duplicates. Remove duplicate entries from the dataset to ensure data cleanliness. Cleaning the text. Remove emojis from text data if they are not needed for analysis. Removing the punctuations, links, and mentions. Cleaning the text data by eliminating punctuation marks, hyperlinks, and mentions, for an example, Twitter handles. Cleaning the hashtags. Processing and standardized hashtags, making them consistent for analysis. Filtering out the special characters. Eliminate special characters that may not add value to the analysis. Removing all multiple spaces, ensuring uniform spacing in text data to avoid inconsistencies. Visualization using C1 and Matplotlib. Data visualization is a crucial step for understanding and exploring the dataset. C1 and Matplotlib are libraries used to create visual representations to gain insights into the data. Tokenization using CF-IDF vectorizer. It involves breaking text into smaller units such as words or phrases. It is a tool to convert text data into numerical features, making it suitable for machine learning. Feature selection. Select relevant features from the dataset. Feature selection aims to improve the model performance by focusing on the most important variable and eliminating noise. Then we have splitting the data to train and test. Divide the dataset into two subsets, a training set and a testing set. The training set is used to train the machine learning models, while the testing set is used to evaluate their performance. Then we have building the model. In this step, you create machine learning models for making predictions or conducting analysis. This list includes various algorithms and combinations to experiment with, such as random forest, support vector machine, k-nearest neighbors, XGBoost classifier, and many more. Then next here we have training the model. Train the machine learning models on the training data to allow them to learn patterns and relationships in the data. Then we have Flask framework with SQLite for sign up and sign in. This step suggests the integration of a web framework or Flask with the SQLite database for user registration and authentication, which can be useful for creating user interfaces and secure SSS to your model or analysis. Next, we have exploring the dataset. Examine the dataset thoroughly to better understand its structure, content, and potential insights. Next here we have processing and training the data. Prepare the data and train the machine learning model on the dataset to make it ready for predictions or analysis. Next, we have user gives input. Collect input from the user, which could be text or any other data that you want to analyze or predict. Then, the given input is translated and pre-processed for prediction. Translate and pre-process the user's input so that it can be used as an input for the trained model. Next, here we have trained model is used for prediction. Apply the trained machine learning model to the pre-processed user input to make predictions or generate the analysis results. Final outcome is displayed through front-end. Present the model's prediction or analysis result to the user through a front-end interface, which could be a web application, making the insights accessible and user-friendly. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as template. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. Then we have here .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. Then next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is the home page for the emotion detection from microblocks using novel input representation. This is all about the analysis, about the machine learning NLP. Here you can see that there is a button for sign up. Just click on this button. Enter your username, your mobile number, email ID and your password over here for doing the registration. I have already done the registration, so I am clicking on sign in button. So just enter the username and the password over here which you have created while doing the registration and simply click on sign in button. So here by scrolling down below, here you have to enter your message over here for doing the detection. So let me just enter the message over here. So here you can see that I have entered the text over here that I didn't feel humiliated sadness. Just simply click on submit button. And here you can see that it is showing the label for the emotion for microblocks content is sadness. So the topic for the paragraph is most dependent on the didn't, feel, sadness and humiliated. So depending upon the text or the message you are providing over there, it will detect on which words the message is fully dependent. So now let's click on about button. Here you can see that there are many different graphs where we have used many different algorithms, and based on these algorithms we have got the accuracy, precision, recall and F1 score over here. By simply clicking on the sign out button, you can successfully log out with this. So now coming back to the conclusion part. The summary of emotion detection from microblocks using innovative input representation highlights the importance of the research results and their potential influence on the realms of emotion detection and the data analysis in the digital era. Within this investigation, a fresh input representation technique for microblog was introduced. This approach integrates text, images, and emojis to augment emotion detection capabilities. Our results clearly illustrate the success of these methods in enhancing the precision of emotion detection, capturing subtle emotional nuances, and offering a more thorough insight into the emotional intricacies within microblog discussions. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.